Let's solve this question. This was posted on Reddit by a user, and he had some problem in this question. This is a logarithm question, and this is a pretty easy question. Let's solve this. Uh, Let me change the color. Yes. So let's start. It's given that find the value of a in the first part, and it's given that such that this is the expression that is log to the base a, and argument is 8. It's equals to 3 to the power 4. First of all, you should know a rule of logarithm, a property of logarithm, that is log base x argument y is equals to z. Now you can write this as y is equals to x to the power z. This is a simple property that this base x would go here and it would push z to the power. So it will become y is equals to x to the power z. So now we'll write it down in the same way. While we'll write it down in the same way. For example, this is log. I'll write it down here. Log to the base a, 8 is equals to 3 upon 4, and 8 would be written here, and it would a would push 3 upon 4 in the power. So now we need to calculate a. So if the power would come here, so power would get, the numerator would become denominator, and the denominator would become the numerator. For example, it is 8 and it was 3 upon 4. It would just become, it would flip, it would become 4 upon 3, and this is a. Now what can we write as 8? 8 is nothing but cube of 2, and the power was 4 upon 3. 3 and 3 gets cancelled out, so a would be nothing but 2 to the power 4, and 2 to the power 4 is 16. So we get the value of a as 16. So this was the solution for the first part. Now let's proceed to the second part. In the second part, it's given that let me change color. Let's choose this one. Yes, it's given that we have to prove something. So we'll start with the first of all, we'll start with this one. We'll just take a single term and we'll simplify it. It's given that 3x log to the base x. Okay, so we have something like that, 3x into log to the base 2 in x. Now there is a property of logarithm. For example, if it's written a log to the base b c, so this can be written as a comes in the power of c. Like I can write this as log to the base c to the power a. So this can be written as the uh, first part comes in the power of the argument. So this would be written as, I can write this as log to the base 2 x, and power of x would become 3x. So this was pretty easy. Now we'll proceed to the next part, that is 4 log. We'll not take the signs, we'll consider after writing all the different parts. 16 to the power 8. Okay, so how can we write, actually the main thing in this is to make this base, here it's 2, here it's 16, here it's 4, and here it's 2. So make the base same. That's the main aim of our answer, that we'll make it same. So how will we make same? So it's given that 4 log to the base 16 to the argument 8. So first of all, what can we write? 16 is nothing but 2 to the power 4. Okay, and what is 8? 8 is nothing but 2 to the power cube. As I have already told in this property, that if something is in the power, it also comes down. If a was here, a goes up in the power of c, or it comes down. So if 3 is given over here, 3 would come down. So 3 would be 4 into 3. Now it would be log 2 and 2 to the power 4 in the base. Now if it's something in the base, it comes in the denominator. So if 4 was there, 4 would just come over the denominator, and this would be nothing but log 2 to the base 2, and 4 into 3 upon 4. 4 gets cancelled out, and we are left only with 3 log to the base 2 and 2. And when base and argument are same, the log is 1. So this is the value. Now let's proceed further. So this is nothing but 3 into 1 is 3. Now let's proceed. The third term is given as 6x log to the power log to the base 4 and argument is 8. So this can be written as, I have already told, 2 square and this is 2 cube and this is 6x. Okay, so 6x would be the same. This 3 would come over here into 3 and this 2 would come in the denominator divided by 2 and this would become log 2 to the argument 2. 2 3s are 6, 3 3s are 9x and log 2 base 2 and argument is same. This and this is same. So this becomes 1. So this is nothing but 9x. Now we'll proceed with the other term, that is fourth term. It's log 2x. So there is nothing that we can simplify in this term. Now we'll go to the term on the RHS. Now we'll proceed over there. Yes, so it was given, what's the term there? Log to the base 2. 8x is in the argument and 3x minus 1. Okay, so we can write this as 3x would come over here, 3x minus 1 and this would be log 2 8x. So we'll just leave it in this form. Now let's take the different terms that we have and we'll see that what can we prove this. We'll try to prove it. Let me change the color. Let's go with green. Okay, so the LHS terms were here. I've calculated. First term was this log 2 this x and to the power 3x. Then the sign was of minus and this is was the term, that is 3, and then sign was of plus and the third term was 9x and the last term was this minus log 2x. This is the LHS. Now we'll solve this. See, uh, this term and this term can be solved when there is a property of logarithm that if base is same, for example log base 2 a minus log base 2 b, so it can be written as log base 2 a upon b. This is a property of logarithm. So in this case also you can see that the base is 2 and the base is 2, and so this would be written as log to the base 2 x to the power 3x x to the power 3x divided by x. This can be written like this, and this is plus 9x minus 3. Now we'll solve this further and we'll try to simplify it more. Now this can be written as x to the power 3x minus 1 plus 9x minus 3. Okay, and 3x minus 1 would come over here and we'll be left with log 2x. Now if we just see this, we have arrived at the 3x minus 1 and 3x minus 1. We just need log 2. We have log 2 but we need 8x. 8x. Okay, so okay, uh, let's see what can we do. I think we'll have to open this and there's nothing left to do. We'll have to open this. uh, yes, we'll have to open this. We'll have to split it out, I think, because there is nothing left to, nothing calculation can be done. Yes, so uh, this is where we'll stop. 3x minus 1 log to the base and this would be written as 9x minus 3. Okay, so yes, we can common out 3 from here. Yes, that's the one thing which we can do. Log 2x and 3 would be commoned out and we'll be there with 3x minus 1. So the whole expression would become 3x minus 1 gets commoned out and this is log 2x plus 3 and okay, yes, let me just move erase these terms. So now from here we can write this as 3x minus 1 and log 2x and 3 could be written as 3 log 2 into 2 But why have I written so? We know that log a and a, that means when the base and argument is same, the value is 1. So 3 into 1 is nothing but 3. So I haven't changed anything. Here it was 3 and here also we have 3. Now if we proceed further, this would be written as 3x minus 1, and this is nothing but log 2x plus 3 goes in the power and it becomes log to the base 2 and 2 to the power 3. So it's pretty cool till here. Then we can write this as 3x minus 1. This is again log 2x plus this becomes 2 cube is 8. And now we'll just uh, uh, arrive at our required term. Like we can write, there is also property that you need to know. When the basis is same, for example, log 2a plus log 2b, you can write this as log 2ab. So here we can write this log 2 8 into x, that is 8x. So as you can see, this was our this was our RHS 3x minus 1 and log to the base 2 8x, and here we have arrived at the same term, that is 3x minus 1 and log to the base 2 into 8x. So this was the second one, and now we'll move to the third part. Let me erase. Yes, now it's done. Now let's move to the third part. It's given that we need to solve this equation. Now I'll do it fast. It's given that 3x, so we can write this as log to the base 2x, and 3x would go in the power 3x, and this would become 4 log 2 to the base 4 and 2 to the base 2 to the power 3. This would be 6x plus 2 to the base 2 and 2 to the power 3 and minus log 2x. So now let's solve this. So this is nothing but log 2 x to the power 3x. This will not change, and this would become 4 into 3 upon 4, and log 2 2. This would be 6x into 3 upon 2 log 2 2, and this is log 2x. So we have to prove that this is 0. So yes, we can easily prove this. We'll just arrive in a couple of seconds. Minus 4 gets cancelled. We'll be left with uh, log, this is nothing but 1. So this is 3, and 2 3s are, this is 3 3s are 9x plus 9x, and this is 1, so this is only 9x, and this is minus log to the base x. So let's write it down here. So we are left with 9x minus 3, so this is 9x minus 3, and the first term was log 2 x to the power 3x minus log 2 to the power x to the argument x, and this is okay. So we can write this as log 2 mm, uh, a minus b, no, so it would become x to the power 3x upon x plus 9x minus 3, and let me erase this stuff, and this would become log base 2 x to the power 3x minus 1 plus 9x minus 3. So okay, mm, we need to calculate the value of x from this. We can calculate, this is 0, no? Oh, this is 0. Mm, this would be written as 3x minus 1 again, log 2 to the base x, and this would be again written as 3 3x minus 1. 3x minus 1 gets commoned out, and we are left with log 2x plus 3. 3 could be again written as log 8x is equals to 0. Now either this is equals to 0 or this is equals to 0. If 3x minus 1 is equals to 0, then x is nothing but it's 1 by 3, or this is equals to 0, then log 2 8 is equals to 0, log 2 8x, that means 8x is equals to 2 to the power 0, that is 1, or x is equals to 1 upon 8. So we get two values for x, that is 1 upon 3 and 1 upon 8.